Take a look. What do you notice? Well, you appears to be a 3 by 3 linear or system, and you're right. But you also noticed, oh, wait a minute, I don't have variables in every one of those equations. The first one's just an x and z. There's no y. So how do we solve this? Well, what's kind of cool is it's a little bit easier to solve than the one that we just looked at. Because our goal, again, what's our goal? Our goal is to take three equations, and there's three unknowns in the entire system, and reduce it to a 2 by 2. So, which variable would you like to include in our 2 by 2? Or which one would you like to have missing in our new 2 by 2? Yeah, let's eliminate the y, because we already have an equation without a y. We just need another equation without a y. So let's figure out some way then to combine those two equations such that the y disappears. So let's take equation 2 and equation 3. Multiply, yeah, it looks like just the easy one is just to multiply equation 2 by what? Yeah, that's right, a -2. So doing that then, distribute that -2 all the way across, gives me a -2x minus a 2y minus a 4z equals a -34. My third line remains unchanged, so that's x plus a 2y plus a z equals a 16. That's still my equations 2 and 3. Add those together, I get a -x, y's eliminated, -3z, 16 plus that gives me what, a -18? And I have a new equation there. And I'm going to call that my equation 5. I could call my equation 4, but I already had equation 4 earlier. Remember this one right here, my x plus z? I'm going to use that in my new system. So let's create my new system then. I'm going to take my equation 1, which has already had a y eliminated. My new equation I found, which was a -x minus a 3z equals a -18. So that's my new equation 5. And my x plus z, it's still equation 1, but I'm going to call it my new 4 equation because I'm using it in a 2 by 2 here. All right, so what do? We have what our goal was. Take a 3 by 3 and eliminate it through many different methods to a 2 by 2. We have a 2 by 2. From here, let's reduce and solve. And, whoa! What'd you guys notice? Yeah, looks like if we go right now, we just go straight to the addition method. The x's cancel out or zero out. So I have a -2z equals a -10. Z equals a 5. Look at that. That is kind of slick. So if I looked at my solution set, z is a 5. From there, we take that solution from our 1 by 1, pop it into one of my 2 by 2s, and find out what z equals. I like equation number 4, really easy. And so equation 4 is x plus z, which is a 5, equals 8. And what do you think that's going to be? That looks like x equals 3. Boom. And then let's take our x and z's and plug that into one of our 3 by 3 lines. And, well, that doesn't help in equation 1. So let's go to equation 3. Why not? And again, I just use these 3's and 4's, these markers, just to help me keep clear where these equations are coming from. Without them, I'm going to have to be looking all over the place, and I can kind of get confused. So that's x, whoops. Well, let me just write down x plus 2y plus z equals to 16. We know x now to be 3. Plus 2y plus a 5 equals to 16. 8 plus 2y equals 16. I might be going too fast because I'm so excited. 2y equals 8 y equals a 4. And there's my solution set. This one just happens to be a nice little rolling in 3, 4, 5, but that's the solution to this system. And how do we deal with it? When we were missing an initial value or variable from our initial 3 by 3, use it to your advantage. Find a way to use it to your advantage and go from there.